Okay. Alright. I have a sine and cosine. That's like having apples and oranges. I can't solve it that way. So I have to use trigonometric identity. Okay, turn everything into sine, everything into cosine. But I do have a trigonometric identity right there, which is cosine squared, and I can substitute 1 minus sine squared x. This minus 3 sine of x plus 2 is equal to 0. Now everything is in terms of sine, then I can solve this equation. I'm going to clean this up a little bit. I have a negative sine squared x minus 3 sine of x, and 1 plus 2 is 3 is equal to 0. And I'm going to multiply everything by negative 1. Kevin, would you like me to bring you some lemonade, iced tea, or anything? Cookies, crackers? Would you like to sit up? Thank you. I just want you to be comfortable. Multiply everything by negative 1. Sine squared x plus 3 sine x minus 3 is equal to 0. Okay, I do not have to multiply everything by negative 1. I just like it that way because I like to have a plus on the front. Okay, now when you get here, you try to factor. You're looking for factors of 3 that you can make a 3 out of. There, we don't have anything like that. So that means we have to use a quadratic formula. A is equal to 1, B is equal to 3, and C is equal to negative 3. So we are solving for sine of x. Guess what you have? You have the microwave. Greg, you are free, but you still have a detention. Alright. Alright, so this is sine of x is equal to negative b, negative 3 plus or minus square root of 3 squared, which is 9, minus 4 times a times c, which is negative 3, all that over 2 times a. That is what I have. Yes, ma'am. Is it normal 3? It is. Gosh, you should be in calculus. You're always correcting. All right. Oh. All right, maybe not. All right, we good? All right. So this is sine of x is equal to negative 3 plus or minus square root of 9 plus, and what is that? 12? All that over 2. This is negative 3 plus or minus square root of 21 over 2. So I have two solutions. I have a sine of x is equal to negative 3 plus rad 21 over 2, and I have a sine of x is equal to negative 3 minus rad 21 over 2. You better punch this in your calculator right now while I'm doing it so you can practice also. I'm going to do the first one, which is easy for me. Graphing calculator is negative 3. I can just punch it in, plus, I can go rad of 21, okay, and then hit enter, and I'm going to divide that by 2, hit enter, I get a perfect answer, so I need to approximate that. Oops, go to green, approximate. Nope, let me do it again, messed up. So, negative 3 plus rad 21. Okay, close my parentheses, enter, let me approximate that. Okay, and then divide that by 2. Okay, and this turns out to be x is equal to approximately 0.791. Check my answers, please. Right. So on this one, I'm going to get x, okay, is equal to, okay, negative 3 minus, then I have a rad 21, close my parentheses, okay, approximate that, convert a decimal, divide that by 2, okay, that turns out to be approximately negative 3.791. So this is sine of x. Sine of x. Okay, sine of x can never be lower than negative 1, so I can throw that out. So what I have left is right there. Okay, sine of x equal to 0.7, okay, 91. So I need a new board, so I'm going to clear this board. So I have a sine of x is approximately 0.791. Okay, so I have to solve for x, so that means I have to take a sine inverse. This is not part of the unit circle, so sine inverse of 0.791. So I'm going to go to my sine inverse. Sine, oops, that's tan inverse. Look at that. Sine inverse of 0.791. Hit enter. Make sure you're in radians, otherwise it's going to give you a big number. X is equal to, okay, 0.912. That's what you should have. Okay. Now I do have a domain restriction, it's 0 to 2 pi. Any questions so far? Okay. Now, I took sine inverse. Your calculator only works in the first and the fourth quadrant for the sine inverse. And it gave you the sine is positive in the first quadrant. So that means this was 0.791. When you took the inverse, it gave you that angle, which is 0.912. Okay? So we have one solution, 0.912. That's good. But sine is also positive another quadrant, which your calculator will not give you. It's right here. That's also 0.791. Okay? We know this angle is 0.912. So we have that solution. But we also have to find this angle right there from there to there. So to get this angle, my x is going to be pi, because that's all the way around to here is pi, minus that angle, so minus 0.912. So I'm going to go to my calculator, 3.14, and I'm going to subtract 0.912, hit enter, and I'm going to get x is approximately 2.228. And those are my two solutions. Okay? All right. Let's clear that. Let's go to 20. 2 cosine square x plus 3 sine of x minus 1 is equal to 0. I'm going from 0 to 2 pi. Again, I have sine and cosine. Okay, I can't have that. I have to use a trig identity. So here it is, 1 minus sine squared. X is my trig identity. Okay, so I can plug that in. I have 3 times sine of x minus 1 is equal to 0. The question is, what they're really asking, and you have to have a picture of this. This is a graph. This is going to give you a sine and cosine graph. They want to know where is equal to 0 means where it crosses the x-axis, and that's what we're going to find, just between 0 and 2 pi. Okay? If we didn't have that, if we didn't have this 0 and 2 pi, then we would write the answer as n is equal to 0, 1, 2, blah, blah, 2 pi n and all that. Okay? That's why we have to go actually find the actual values now. Okay? Multiply everything out. That's 2 minus 2 sine squared x plus 3 sine of x minus 1 is equal to 0. Okay, let's clean it up a little bit. Negative 2 sine squared x plus 3 sine of x. The negative 1 and plus 2 is going to give you plus 1 is equal to 0. Multiply everything by negative 2 sine squared x minus 3 sine of x plus 1 is equal to 0. Let's cross our fingers. Hopefully we can factor this. Okay, looks like we can. I get a 2 sine x. I get a sine x. Factors of 1 is 1 and 1. I need to make negative 3 in the middle, so both of these are negative. Okay, does that work? It looks like it does. So sine of x minus 1 is equal to 0, and sine of x 2 sine of x minus 1 is equal to 0, and sine of x minus 1 is equal to 0. Solve for this, I get sine of x is equal to positive 1/2. And solve for this, I get sine of x is equal to 1. Okay, that was easy. Now I just have to go find out where in the unit circle is. So we're just going around circle once in the positive direction. Okay, sine is equal to 1/2 here. That's 1/2 there. That's going to be pi over 6. Sine is equal to positive 1/2 there. That is 5 pi over 6. For those of you that still have to draw a unit circle to get the answers, you're in trouble. Okay, and then sine is equal to positive 1 right there, which is pi over 2. So I have 3 solutions. X is equal to pi over 6, pi over 2, and 5 pi over 6. And those are the 3 places this graph will cross the x-axis between 0 and 2 pi. Okay. 21. Sine x times cosine x is equal to 1 over 2. Okay, so if you were to graph this, they want to know where it crosses x is equal to 1/2. Okay, which y is equal to 1/2, which is a horizontal line. Well, we can't solve that as this, so I'm going to multiply everything by 2. So I'm going to get 2 sine x cosine x is equal to 1. All right, but we have a trig identity for this. And that is sine 2x. Okay? Sine 2x. Now we do have domain restrictions 0 to 2 pi. Okay? Now what we're asking is this box right there, what can I put in that box? Take sine of that and get 1. Well, sine is equal to 1 only one place between 0 and 2 pi. And that's right there, which is pi over 2. So therefore, the only thing that can be is pi over 2. Right? So what I have is, now, because this is a 2x, you got the microwave. You're free of microwave, but you still have to clean up duty. We're going to have a party in here today, Wolverine time. Okay. Now, this is the problem. Now pay attention. Even though I have an interval right there, the only way I can solve for this is I have to rewrite this as 2 plus or minus 2 pi n, and n is equal to 0, 1, 2, 3. The reason for that is I have a 2x. If I didn't have a 2x, if I just had an x, that would be my answer. Okay? So I'm going to write this. 2x is equal to pi over 2 plus or minus 2n pi, and n is equal to 0, 1, 2, dot, 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 dot. It would have been easy if I just had an x, but I have a 2x. Now I have to divide everything by 2. X is equal to pi over 4 plus or minus n pi. Now I have to plug and chug. First number I'm going to put in for n is 0. When I put 0 there, I get x is equal to pi over 4. Is that less than 2 pi? Yep, I keep it. I go n is, now I don't have to worry about the negative direction because it's only going from 0 to 2 pi, so I might as well erase that. I don't need that. Okay? So now I'm going to go n is equal to 1. Okay? So I'm going to get x is equal to pi over 4 plus pi, which is 5 pi over 4. Is that less than 2 pi? Keep it. Then I'm going to go n is equal to 2, which is going to give me x is equal to pi over 4 plus 2 pi. I can stop there because that goes beyond 2 pi. So I have 2 solutions. Okay. So now we're down to 10 through 19. I already did 14 and 18, so those are excluded. Okay, what would you like to see? Yes, Zach. 15, that's a hard one. 17, I think that's a hard one. 13, 12, 18, 16. Okay, let's start with 12. 12, 13, 15, 16, and 17. All right, 12. 12 says, I have a 2 sine squared x plus 3 sine of x plus 1 is equal to 0, and I have a domain restriction 0 to 2 pi. Okay. All right. Let's cross our fingers it doesn't turn out to be a quadratic formula. Okay. If it does, then it might get nasty. But one thing nice about this is everything is in terms of sine. That's good. It has just an x. It doesn't have like a 3x or 5x, which is good. Okay. Now we're going to try to factor. Okay. And what are factors of that? Which is 2 sine x and sine x. And factors of 1 is 1 and 1. Okay. They both have to be plus. So I'm going to set each factor equal to 0. I get sine of x is equal to negative 1/2. I get sine of x is equal to negative 1. We're in good shape. Factored. Okay, we just have to go around the circle just once in the positive direction. Okay, sine x is equal to negative 1/2. Where? It's going to be negative 1/2 there, which is going to be 7 pi over 6. And sine of x is equal to negative 1/2 there. So that's going to be 11 pi over 6. So I have two answers. And I have sine of x equal to negative 1. And that's going to be down here, which is 3 pi over 2. And those are my answers. Okay, x is equal to 7 pi over 6, 3 pi over 2, and 11 pi over 6. And that's done. Alright. So the next one is 13. So let's go to 13. 13. I have a 4 sine cubed of x minus sine of x is equal to 0. I still have a domain restriction 0 to 2 pi. Those are the only values I'm looking for. I can factor this. I can pull out a sine of x, and that will leave me with a 4 sine squared x minus 1 is equal to 0. This has a special name. That's difference of two squares. So I can factor some more. So that factors to 2 sine x plus 1, 2 sine x minus 1 is equal to 0. It's factored. Okay, that's great because it's going to work out nice and easy. I said each factor equals 0. I get sine of x equal to 0. I get sine of x is equal to negative 1/2. And I get sine of x is equal to positive 1/2. Now it's just a matter of my unit circle. Okay, sine x is equal to 0 between 0 and 2 pi here, here, and here. Do you want to do the microwave? This is my signature. What's this? Is this from Miss Hubschmidt?
Yeah.
I guess she wants money. There you go. Welcome. Alright. So, for this, I have x is equal to 0, pi, and 2 pi. And then, where is sine equal to negative 1/2? We just figured that out just a second ago. That's going to be right there, 7 pi sixth, and then 11 pi sixth. So I get x is equal to 7 pi sixth and 11 pi sixth. Okay, where is sine equal to positive 1/2? That's going to be pi sixth and 5 pi sixth. So from this, I'm going to get x is equal to pi sixth and 5 pi sixth. These are all. That's 4 plus 3, which is 7 solutions. So what that means is, between 0 and 2 pi, this graph will cross the x-axis 7 places. And we found all the places it crosses the x-axis. Right? And when you get to calculus, if this is the derivative of a function, this is where the velocity changes from positive to negative. That means the rocket's going up, coming back down, going back up, coming back down, so on and so forth. But that's the lesson for another day. Alright, number 14. You have 6 cosine of x plus 1 is equal to 5 secant of x, 0 to 2 pi. Again, I have secants and cosines. Can't have that. I have everything in terms of cosine. So I'm going to write 6 cosine of x plus 1 is equal to 5 over cosine of x, because that's what secant x is. Multiply everything by cosine. Well, 6 cosine squared x plus cosine of x is equal to 5. It's a quadratic. Take everything to one side. 6 cosine squared x plus cosine of x minus 5 is equal to 0. Cross our fingers. Hopefully we can factor. Otherwise it's going to get ugly. Factors of 6. I can go 6 and 1. I can go 3 and 2. Where you want. There you go. Factors of 5 and 1. But I got to make a 1 in the middle, so I better put 5 here and 1 there. And I need a negative, so I better put negative on the 5 and plus on the 1, and that works. So now I'm going to solve for cosine of x. So cosine of x is equal to 5 over 6. That's ugly. Cosine of x is equal to negative 1. That's okay. Let's go ahead and take care of this. Where is cosine equal to negative 1 on the unit circle? Okay, only one place right there. From 0 to 2 pi. So from this, I'm going to get x is equal to pi. That's done. This is a mess. That's not part of the unit circle. So if it's not part of the unit circle, you have to go to your calculator and do what? Take what? Inverse. Very good. So let's go there. So my x is equal to cosine inverse of 5 over 6. Okay? So I'm going to go, better punch in your calculator so you know how to do it. So cosine inverse, okay, 5 divided by 6. Hit enter. I hate that. Okay. So this turns out to be 0.586. Did you get that? Okay. You didn't get that? Okay. Anybody else? You got that? Okay. Alright, so what this means is, remember, cosine is positive here. Okay, this is my 5/6. That's my 5/6. What your calculator gave you is that angle right there. That's 0.586. That's what your calculator gave you. But there's someplace else on the unit circle where cosine is positive. It is in the 4th quadrant. That means you got to go find this angle right there. That's 2 pi. So x is going to be 2 pi minus 0.586 because I can't go to negative direction. So that would be 6.28. 6.28 minus 0.586, okay, equal to, x is equal to 5.654. That's one of my answers. This is other answer, and I have 3 answers right there. And I have a pi. Okay. Pretty neat. Well, okay. So I know I have another angle here. Pay attention. I now have another angle right there. Okay? Because that's the same triangle. Cosine is positive here. Okay? This angle here is 0.586. Okay? That's the angle on the triangle. But on the circle, I have to go all the way around to here and stop right there. Okay? That's 2 pi minus 0.586. Okay? If you go in this direction, that would be negative. So I could write negative 0.586, but that says it'll go only in the positive direction. It's like you could negative pi 6 is same thing as 11 pi 6. Do you see what I mean? I can't write negative pi 6 because I have to go positive direction. Okay? All right. 14. All right, here comes number 15. You better pray tonight like I don't put this on the test. Okay, this is 0 to 2 pi. All right. Got to take everything one side because it's quadratic. This is a tangent squared x minus tan x minus 1 is equal to 0. Okay? Factor. Tan x, tan x. Factors of 1. Can't do it. So, that's gone. Only blessing we have is that it's just an x, it's not like 3x or anything inside. So I have to go to quadratic formula. So what's my quadratic formula? My a is 1, my b is negative 1, and my c is negative 1. I'm solving for tan x. I'm not solving for x right now. I'm solving for tan x. So negative b is going to be 1 plus or minus square root of 1 square. Negative 1 squared is 1 minus 4 times a times 1, which times c, which is negative 1, all that over 2 times 1. This goes 1 plus or minus square root of a 5 on the inside, all that over 2. So I get two solutions, x is equal to 1 plus rad 5 over 2. I get the solution, x is equal to 1 minus rad 5 over 2. Punch in your calculator. Okay. Practice. 1 plus rad 5. Okay, close parentheses. Okay. And divide that by 2. Alright. I get x is equal to, or tan x, tan x. Tan x is equal to 1.618. And let's do the minus. Okay, so let me go back. Yeah, might as well punch it in. 1 minus square root of 5. Okay. Divide that by 2. And I get tan x is equal to negative 0.618. Alright, I'm solving for x. That means I take inverse of both sides. X is equal to tan inverse of 1.618. Okay, so I'm going to go tan inverse of 1.618. Okay, and this turns out to be x is approximately 1.017. And I'm also going to do the tan inverse. This is going to be x is equal to tan inverse of negative 0.618. So might as well just clear this one out and then get in negative 0.618, close my parentheses. Okay, and this turns out to be approximately negative 0.554. Okay. I have two solutions, 1.017 and negative 0.554. I need more space. So I'm going to clear this out. Okay, x is equal to 1.017, and I get x is equal to negative 0.554. Alright, I do have a domain restriction here that is going from 0 to 2 pi. Okay, this angle, okay, is this angle right there, 1.017. Okay, that's where the tangent was positive. There's one more place where tangent is positive. Tangent is positive down here in the third quadrant where both sine and cosine are negative. So this angle, because these are, if you remember from geometry, these are vertex angles. So therefore that's 1.017 also. But you can't write 1.017. You have to go all the way around here. That's pi plus 1.017. So your x is equal to pi plus 1.017, which is really 3.14 plus 1.017, which is really 4.157. So I have two answers so far. That's done. Now I have to go over here. The angle that I'm given, because my calculator is not very smart, it only deals with first and fourth quadrant for tan inverse. This is the angle it gave me. But I can't use that because I'm going from 0 to 2 pi. It's like same concept. Like it's giving me like negative pi 6, but I can't say negative pi 6 because I have a domain restriction here. So another name for negative pi 6 is 11 pi 6. That means I got to go all the way around to get to that spot, which would be, Brittany, 6.28 minus 0.554, right? 5.729. There we go. Okay, do you see why? Okay. All right, there's one more place where tangent is negative. Okay, tangent is negative here. Okay, this is the angle I have. That angle is 0.554. Okay, that's the angle I have from the calculator. So I have to find from here to there what is in the unit circle. That's going to be x is equal to pi minus 0.554, which is x is equal to 3.14 minus 0.554. And what is that, Brittany? There we go. I have 1, 2, 3, 4 solutions. All right. So some of you now going, okay, this isn't bad, I can do this. Some of you going, I understand, I don't know if I can do it. Some of you like, I have no clue. What's going on? Here we go. Number 16. I think that's another hard one. 2 cosine squared x minus 5 cosine of x minus 1 is equal to 0. Oh, I tell you what, when you get to calculus, this problem, this is easy because I have an x, it's quadratic. This problem can turn out to be 2 cosine squared 5x plus 2 minus 5 times cosine of 5x minus 2 minus 1 is equal to 0. And that gets nasty. Okay? So you're going to get that. But baby steps, I guess. Alright, here we go. Can we factor this? I don't think we can factor it, so we might as well go to quadratic. A is equal to 2, B is equal to negative 5, and C is equal to negative 1. Alright? So when we get to that, we can go, we're solving for cosine of x is equal to negative 5, which is 5 plus or minus square root of negative 5 squared, which is 25, minus 4 times a, which is 2, times c, which is negative 1, all that over 2 times a, which is 2. If I clean this up, I'm going to get plus 5 plus or minus square root of 25 plus 8, which is going to give me 33. All that over 4. So I have two solutions. I have cosine of x is equal to 5 plus rad 33 over 4. And I have a cosine of x is equal to 5 minus rad 33 over 4. Okay? So let's go over here. Let's crank this out. I have a 5 plus rad 33. Okay? And then I'm going to divide that by 4. And that's going to give me cosine of x is equal to 2.686. And that's good news. What's so good about this? Too big. Okay? So we can move on to the negative one. Okay? So negative 1 will be 5, okay, minus rad 33, okay, divide by 4. That's not too big. Cosine is equal to negative 0.186, so we have to work this out. That's the most cosine can be is 1. The least cosine can be is negative 1. As long as between 1 and negative 1, we're good. We'll get solutions. Okay, so x is equal to cosine inverse of negative 0.186. So I'm going to go to cosine inverse of negative 0.186. Hit enter. So my x turns out to be, angle is 1.758. Okay, cosine is negative in this quadrant. My calculator only works in the first and the second. So it gave me this angle right here. Okay, that angle is what I have. Okay, that's 1.758. That's the angle that my calculator gave me. But I can't use that. I have to start here and go to there. So what's my real angle? X is equal to pi minus 1.758. Okay, so that'll be 3.14 minus 1.758. Okay, and which is going to give me x is equal to 1.382. That is my actual answer. I cannot use that because it just gave me an angle in the triangle. That's all it gave me. Okay, I have to put that in with respect to my unit circle. Alright, cosine is negative one more place. Cosine is negative in this quadrant. This angle, I know what that angle is. That's my 1.758. So how do I find the angle from here to there then? That's going to be x is equal to 3.14 plus 1.758. Okay, so 3.14 plus 1.758, and that turns out to be my x is equal to 4.898, and there it is. Alright, we're almost done. We still have some time to relax and get ready for the microwave. Number 20, or no, 17, last one in this section. 17. Sine of x, cosine of x, plus cosine of x is equal to 0. I can factor. Take out a cosine of x. All that times sine of x plus 1 is equal to 0. Set that equal to 0. Cosine x equal to 0. Set this equal to 0. I get sine of x is equal to negative 1. This piece of cake. I'm going from 0 to 2 pi. Let's take care of that. Where's cosine equal to 0? Between 0 and 2 pi. Here and here. It's pi over 2 and 3 pi over 2. So from this, I get pi over 2 and 3 pi over 2. Where is sine equal to negative 1? right there, 3 pi over 2. I already have that. So that's done. Okay, so I have 1, 3, 5, 7, and 9. Everything else I did in that section. It looks like I've pretty much done every problem in this section. So if you're missing a problem in homework, oh, you're in big trouble. What do you like to see? What do you want to see in this? Pick. Nothing? We're good in this section? 1, 3, 5, 7, 9. We're good to go. We don't need that? I didn't do those. Those are the ones I haven't done. 3. Anything else? 5. 9. All right. I have 3, 5, and 9. All right, if you want me to take the test for you tomorrow, just bring a $20 bill. I'll take tests for you. But if you want me to get a good grade on it, bring me a $100 bill. All right, here we go. This one does not have a domain restriction, but we have a problem. 5x. Okay? Good news, no domain restriction. Bad news, I got 5x. Okay? So let's go ahead and solve for this. Sine of 5x is equal to negative rad 3 over 2. So I can go to the unit circle because that's part of the unit circle. Where is sine equal to negative rad 3 over 2? It's negative rad 3 over 2 there because that's negative rad 3 over 2. And that happens to be 4 pi thirds. It's also negative rad 3 over 2 there. Okay, now because I don't have domain restriction, I can write minus, okay, pi thirds also. Or I can write 5 pi thirds. Either one is fine. Minus pi thirds and 5 pi thirds. But here's the problem. Okay, this box right there could either be 4 pi thirds or 5 pi thirds. So my 5x is equal to 4 pi thirds. Because I'm going around the circle forever and ever, I don't have a domain restriction. I have to write this as a plus or minus 2n pi. My n is equal to 0, 1, 2, dot, dot, dot. And then I also write 5x is equal to 5 pi thirds plus or minus 2n pi. Okay, I'm solving for x. I got to divide everything by 5. X is equal to 4 pi over 15 plus or minus 2n pi over 5. And here x is equal to pi over 3 because the 5's will cancel out. Okay, plus or minus 2n pi over 5. And that, along with 0 is equal to 1, 2, 3, 4 is my answer. If you don't write 0 is equal to 1, n is equal to 1, 2, 3, 4, you will lose points. You have to write that somewhere. Okay. Yes. Now, if I had a domain restriction from 0 to 2 pi now, then I have to plug and chug. Crank it out. Got that, Mr. Taylor? That's what you say. Okay, number 5. Now I'm in trouble. 2 sine of 3x is equal to 1. And that's on the interval from negative pi to pi. Okay. Now here's the good news and bad news. I have an interval restriction. That means I'm going around the circle there, and I'm also going around the circle there. That's my negative pi. But this was an x, that would be great. So I just have to go around circle left, to the left and then to the right, to the bottom. But because of 3x, I have to write as a n is equal to 0, 1, 2, 3, 4, and I have to plug and I have to crank them out. Okay? So that is a mess. So sine of 3x is equal to 1/2. Now just go to my unit circle, find where sine is equal to 1/2. Sine is equal to 1/2 there, which is pi over 6. Sine is equal to 1/2 there, which is 5 pi over 6. So this box right here can either be pi over 6, or that box can be 5 pi over 6. So I write this out as a 3x is equal to pi over 6 plus or minus 2n pi. My n is equal to 0, 1, 2, dot, 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 dot. And I write 3x is equal to 5 pi over 6 plus or minus 2n pi. Solve for x. X is equal to pi over 18, okay, plus or minus 2n pi over 3. And solve for x. X is equal to 5 pi over 18 plus or minus 2n pi over 3. Not done because it's domain restriction right here. That causes me to plug in for the n now, okay, and find everything between 0 and pi and 0 and negative pi. Okay, so let's go ahead and do that. Okay, I'm going to let my n is equal to 0 first. See what my x is equal to. If it falls within my domain, I'm in good shape. So let my n is equal to 1. So I'm working on this right now. Okay, so my x is equal to, this is going to go away. So x is equal to pi over 18. Is that less than a pi? Yep, we keep that. I'm going to let my n is equal to 1. Okay, and I have to go both directions because I'm going negative direction too. So n is equal to 1 is going to give me x is equal to pi over 18, okay, plus 2 pi over 3. Okay, that common denominator is 18, so that this turns into 12. 12 plus 1 is 13, so this is 13 pi over 18. That's less than 1, so I keep it. I have to go in the negative direction. X is equal to pi over 18 minus 2 pi over 3, because I'm going in the negative direction too. I'm going negative pi, so I can get a negative answer. So this is, again, this turns out to be 12, okay, when I find a common denominator. So this turns out to be negative 11 pi over 18, and that's within negative, less than negative pi, so that's going to stay. Now I'm going to try n is equal to 2. Okay, I'm going to get x is equal to pi over 18 plus 4 pi over 3. Okay, this now, when I find a common denominator, that turns into 24. Okay, 24 plus 1 is 25 over 18. 25 over 18 is bigger than a pi, so I can stop right there. And same thing happens in the negative direction, so that's done. Okay, so I have taken care of only half of the problem. Now I got to take care of this other half. So I found 3 answers so far, so I have to find, there's going to be 3 more because sine and cosine functions tend to have symmetry. Okay? Alright, so let's go here, and I'm going to let my n is equal to 0. When n is equal to 0, my x is equal to 5 pi over 18, and that's less than a pi, so I keep that. I'm going to let my n is equal to 1. That's going to give me x is equal to 5 pi over 18, okay, plus, okay, 2 pi over 3. Again, that turns into 12 because a common denominator. 12 plus 5 is going to give me 17. X is equal to 17 pi over 18, and that is still less than a pi, so I keep that. I'm going to go to the negative direction. X is equal to 5 pi over 18 minus 2 pi over 3. Again, that turns into 12. So I have a 5 minus 12, which is a negative 7 pi over 18. That's still within, inside that negative pi, so I keep that. And then when I go n is equal to 2, it becomes too big, so I can stop there. So I have 1, 2, 3, 4, 5, 6 solutions. Okay, I think the last one is number 9. Here we go. The hardest one is number 7. But you didn't ask for it, so I'm not going to do it. Alright, number 9. This has no domain restriction, so we're in good shape. Okay, take this to the right. I get 2 cosine of x is equal to negative 1. Divide by 2, cosine of x is equal to negative 1 over 2. Okay, where is cosine of x equal to negative 1 over 2? Okay, it's negative 1 over 2 here, because that's negative 1/2. Okay, that happens to be 2 pi over 3. Okay, it's also negative 1/2 there. That happens to be 4 pi over 3. So my x is equal to 2 pi over 3 plus or minus 2n pi. And my x is equal to 4 pi over 3 plus or minus 2n pi. And my n is equal to 0, 1, 2, dot, 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 dot. And that's it. Alright. So, today was my turn to teach you. Tomorrow is going to be your turn to teach me. If you're a bad teacher, you're going to get a bad grade. Okay? If you're a good teacher, you're going to get a good grade. Yes? Three decimal places. Yeah. That's why I have to check the work. It's going to be within the ballpark. Yeah. Not everyone's going to have exact same answer.